Hello everyone. Today we are doing prime factorization and exponents lesson 5. And we are focusing on integral exponents, or more specifically, negative exponents. So up until this point, we've only been dealing with positive exponents, and today we're going to look at how to deal with the negative ones. So the unit or the lesson here starts off with a couple of patterns, and we're going to use those to explore what happens when an exponent becomes negative. So if you look at the left side here, we have 10 to the power of 3, and that's equal to 1,000. And then 10 to the power of 2 is 100, and 10 to the power of 1 is 10. And you can see what's happening is as we move down the row, or the column, the exponent is going down by 1 each time. So we will go to 10 to the power of 0, and we know that anything to the power of 0 is 1. That's the 0 exponent law. And then it shows you here that if we go 10 to the power of negative 1, that's the next one down, right? If we keep this up, we get this fraction 1 over 10, or 1/10. And then 10 to the negative 2 would be 1 over 100. And 10 to the negative 3 is 1 over 1,000. And those can be rewritten. So you see 1 over 10 can be rewritten as 1 over 10 to the 1. 1 over 100 can be rewritten as 1 over, well, we know 100. Up here we already said that 100 is equal to 10 to the power of 2. So now we can say, well, 1 over 10 to the power of 2. And 1,000 we know is equal to 10 to the power of 3. So 1 over 10 to the power of positive 3. Then they've got the same thing but with base 3. So we have 3 to the power of 3 is 27. 3 to the power of 2 is 9. And 3 to the power of 1 is 3. And then we are going to follow the same pattern we did with the tens here. So 3 to the power of 0, anything to the power of 0 is 1. 3 to the power of negative 1 becomes 1 over 3. And 3 to the power of 2 becomes 1 over 9, 1/9. And then 3 to the power of negative 3 is 1 over 27. We can rewrite these as 1 over 3 to the power of 1, 1 over 3 to the power of 2, because 9 is equal to 3 to the power of positive 2, and 1 over 3 to the power of positive 3. So what we're starting to notice here, or hopefully you're starting to notice, is that, let's stay with black. A to the power of 0 is 1. So what happens here when we have a to the power of a negative exponent? Well, you can imagine this like a fraction. A to the power of negative 1 over 1. And anytime, this is how I remember negative exponents, and this is going to explain the whole lesson in one little go here. Anytime you have a negative exponent, that's an unhappy exponent. So it's not in the right spot. So what you want to do is, if the negative exponent is in the top of the fraction, so like it is here, a to the negative 1 is in the top of the fraction, put it into the bottom of the fraction. So what I'm going to do is just move it to the bottom of the fraction. So if I take it off the top, there's nothing left, so I have to put a 1 there, over a to the power of positive 1. So now it's happy, it's positive, it's going to go to the bottom. Same with right here, a to the negative 2. Imagine that as a fraction over 1. That negative 2 is unhappy, so I'm going to flip it. I'm going to put it in the bottom, 1 over a to the positive 2. And that makes it happy. And we can deal with positive exponents even if they're in the bottom of a fraction. And last but not least, we have a to the power of negative 3. That is an unhappy exponent. It's over 1. Anything can be written over 1. It's an unhappy exponent. I'm going to flip it to the bottom to make it happy. A to the power of positive 3. So with that in mind, let's try a few examples. Write the following with positive exponents. So again, we can write anything over 1. All of these can be over 1. So what's going to happen is I have 10 to the negative 7, That is an unhappy exponent. So what I'm going to do is just put that term, just this one, into the bottom. And when I do that, there's really nothing left in the top of the fraction. So we're going to put 1 as a place value there, or a placeholder, and then we're going to put 10 to the power of positive 7. And that's it. Same with here. 3 to the power of negative 5 is unhappy. So what I'm going to do is flip it and make the exponent positive. And a to the power of negative n, I will flip it and have a to the power of positive n. That's it. And it works both ways. If we had, we're going to see an example of this, if we had 1 over a to the power of negative n, that would become just a to the power of positive n over 1, but we don't have to write that. We flip that fraction. So if the negative's in the bottom, we put it on top. If the negative exponent's in the top, we put it on the bottom. So we have been doing some exponent laws up to this point. Hopefully you're starting to remember them and get them memorized a bit and just feel natural with them. And so here's a good example of that. We have 5 to the power of 4 divided by 5 to the power of 7. Normally when we do that, the larger exponent's in the front so that our answer is always a positive exponent. But in this case, we have 5 to the power of 4 in the top divided by 5 to the power of 7. So we're going to have 7 5s. I don't know if I'm going to have enough space. 1, 2, 3, 4, 5, 6, 7. Perfect. And what we're going to do is cancel these. So that one cancels, that one cancels, that one cancels, that one cancels, and we're left with 3 5s on the bottom. So that is 1 over 5 to the power of 3. And so we know that because if we were to do this with the quotient law, which we learned a couple lessons ago, when we divide powers with the same base, we subtract the exponents. So here, we're dividing powers of the same base. 5 is the base. We're going to subtract those exponents. 4 minus 7. I'm not going to use that little box because I think it's really impossible for me to write in those boxes. 4 minus 7 is 5 to the power of negative 3. So we want to flip that. We don't want to leave our answer with a negative exponent. So we are going to make that exponent happy by putting it, right now it's in the top of the fraction. We are going to put it into the bottom of the fraction. And you can see here we get the same answer. So I'll go over a couple more of the examples. With E here, write the following with positive exponents and evaluate. Well, again, if it's just one term, you imagine it as a fraction over 1, and you want to make it happy, so you go 1 divided by 2 to the power of positive 1. You just flip it and change the exponent sign. Same with this one. The exponent is negative, so it's unhappy, so I'm going to put it in the bottom and make it a positive. And this one here, 4 to the power of negative 3, that's an unhappy exponent. So I'll put it at the bottom of the fraction, and it becomes a happy exponent or a positive exponent. So what happens if it's in the denominator? I kind of already touched on this. So the example they have here is 1 over 4 to the power of negative 3. That's an unhappy exponent, but it's in the bottom this time, right? That unhappy exponent's in the bottom, so it means it's not in the right spot. So what we want to do is, instead of before we were moving a negative exponent from the top to the bottom, now we're going to go from bottom to top. So this becomes 4 to the power of positive 3 over 1, or if you want to write it nicer, just 4 to the power of positive 3. So it can be summed up in a nice, neat law here. It's the negative exponent law. So if you have a negative exponent, you just end up flipping it, and it's shown right here and right here. It shows both scenarios, where the negative exponent is in the top of the fraction and one where the negative exponent is in the bottom of the fraction. So now we're going to do some examples. I think it's just this page. and then we're done. Oh, no, it's 2 more pages. I lied to you. That's okay. I'll do every second example. How about that? So simplify, express with positive exponents, and evaluate without using a calculator. Well, I mean, I'm never going to ask you to do anything without a calculator, so I wouldn't worry too much about that. But here we go. 4 to the power of 5 multiplied by 4 to the power of negative 3. So we are dealing with powers with the same base, so we can use the product law. So the base is going to stay 4. And when we multiply powers with the same base, we add the exponents. So it's 5 plus negative 3. And 5 plus negative 3 is 2. So we have 4 to the power of 2, and we can evaluate that. 4 to the power of 2 is 4 times 4, so we get 16 as our answer. I'm going to do D. Let's do D. 6 to the power of negative 7 divided by 6 to the power of negative 5. When we divide powers with the same base, we subtract exponents. So we are going to keep our base, and we're going to subtract our exponent. Negative 7 minus negative 5. So this becomes 6 to the power of negative 7 minus negative 5. And if you remember, if you have 2 negatives in a row, you chop and make them positive. So it's negative 7 plus 5 gives us 6 to the power of negative 2. And then that can't be our final answer because we need positive exponents. So if we have an exponent that's negative, it's unhappy, we need to flip it. So it becomes 1 over 6 to the power of positive 2. And then we want to evaluate that. 6 to the power of 2, or 6 times 6, is 36. So our final answer is 1 over 36. Hopefully that made sense. I really want to go over E as well, so I'm going to do it in the margin over here. So I have 2 to the power of 3, all to the power of negative 1. And you remember when we do a power to a power, we multiply them. So 2 to the power of positive 3 multiplied by negative 1 gives us negative 3. That's an unhappy exponent. So we want to flip it. 1 divided by 2 to the power of positive 3. And then we want to evaluate that 2 to the power of 3. We want to calculate that. 2 to the power of 3 means 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, and we get 1 over 8. Hopefully that makes sense. Okay, I want to go over this example right here. Explain why 2p to the power of negative 3 does not equal 1 over 2p to the power of positive 3. This is a does not equal sign. Hopefully you've seen that before, but if you haven't, it's an equal sign with a cross through it. It means does not equal. Why doesn't that equal? It seems to make sense. What we've learned so far is that if you have a negative exponent, you flip it. But what you have to be really careful of is 2p to the negative 3. That negative 3, this negative 3 exponent here is only acting on that p. So that's the only part that you're going to flip. That means what it should equal is 2 in the top of the fraction. That 2 right here stays in the top, and that p to the power of positive 3 comes into the bottom. So this is the actual answer, not this. You see how they brought the 2 to the bottom? You don't want to do that because the negative exponent does not act on the 2. If, for example, we had 2p all to the power of negative 3, then the answer would have been that, because we would have moved that whole term down to the bottom to make it happy. But there were no brackets, so that means the 2 was not part of the base. Carry on. This might be our shortest video yet. Hopefully we can keep moving here. Let's do B, D, and F. How about that? Okay, so we have 6x squared divided by 2x to the power of 7. So the first thing we want to deal with is the coefficient we have 6 divided by 2. We know what that is. If it's easier for you, I like to do it 6x squared over 2x to the 7. It just it makes it easier for my brain to work because now I see that I'm going to go 6 divided by 2, and 6 divided by 2 is 3. That's easy. And now we have exponents with the same base, and we're dividing them. So we are going to subtract. So we have 2 minus 7 is going to give me negative 5. We know that we don't want negative fractions, so I can go one step further and say, well, I'm only going to flip the x to the power of 5, not the 3, because the 3 doesn't have that negative 5 exponent. So our answer becomes 3 over x to the power of 5. Hopefully that made sense. Next, we have negative 2x to the power of negative 3. So the first thing I want to do is deal with that unhappy exponent. So I can just rewrite this as 1 over negative 2x to the power of positive 3. And we've dealt with that exponent. It's happy now, it's positive. And now we can deal with these brackets here. That 3 is going to act on both terms in that exponent, or in that in those brackets, sorry. So we have 1 over negative 2 to the power of 3, x to the power of 3. And the last thing we can do is we actually can solve this, right? That is an actual number, so it's not a variable. So we are going to negative 2 multiplied by negative 2 multiplied by negative 2. Negative 2 to the power of 3. Negative 2 times negative 2 is a positive 4. Multiplied by negative 2 is a negative 8x to the power of 3. Perfect. That's our answer right there. Negative 8, or 1 over negative 8x to the power of 3. And just a quick note with fractions, that can be, the negative can be on the bottom. It can also be on the top. That's the same thing. Or it can be right in the middle. Oh, what happened there? Those are all the same. Whether the negative's in the bottom, the top, or right in front, that whole term is going to be negative. So it's all the same. You'll get the right answer if you put the negative in the bottom, the top, or right in front. I'm going to erase those just for space. All right, I've been talking lots, so hopefully you guys are learning lots. That's the goal. So we have the last question in this section here, 5p all to the power of negative 2 divided by 5q to the power of 4. And you can see right away that we have a negative exponent. So that means this entire term is unhappy. And what do? Well, we're going to move it to the bottom. We're going to put it in a place where it's going to be happy. So now what we have is, well, we have to put a 1 in the top because there's nothing left in the top of that fraction. And we have 5q to the power of 4 multiplied by, in brackets, 5p to the power of positive 2. And then what we're going to do is we're going to distribute that 2. The 2 is going to act on the 5 and the p. So I'm going to rewrite that as 1 over 5q to the power of 4 multiplied by 5 squared multiplied by p squared. And then I'm going to deal with my 5s. I have 5 multiplied by 5 squared. I know that 5 squared is 25. So 25 multiplied by 5 is going to be 100. Oh, shoot, it's on the bottom of the fraction. Let's do it right here. 1 over 125. That's 5 multiplied by 5 squared. And then I'm just going to leave my variables because I can't do anything with them. A q and a p are different variables. Q to the power of 4, p to the power of 2. And that's my final answer. Here we have an entire fraction all to the power of a negative exponent. So what happens when we have this unhappy exponent acting on an entire fraction? You see those brackets mean that the exponent is acting on the 2 and the 3. So what you want to do in this case, I'm not going to worry too much about this, is you're going to put that 2 into the bottom and put that 3 into the top. They're both not in the right spot, and I'll show you why. Normally when we have 2 over 3 to an exponent, that exponent acts on the top and on the bottom. So we can rewrite that as 2 to the power of negative 4 over 3 to the power of negative 4. And when we have a negative exponent, we flip it. So the top term goes to the bottom term goes to the top, and we have 3 to the power of positive 4 over 2 to the power of positive 4. So what you can do, instead of doing all of these steps, is if you see that same question, 2 over 3 to the power of negative 4, you can just flip everything inside the brackets. So now 3's on top, 2's on the bottom, and make that exponent positive 4. It's the same thing, and that's what they've got written right there. So it says here, suggest a quick method for evaluating 5 over 2 to the power of negative 3 without using a calculator. Well, what we can do is, let's just flip that fraction. Let me get back to my black here. 2 over 5, all to the power of 3. And then we can distribute that in. 2 to the power of 3 over 5 to the power of 3. And then we can just simplify. 2 to the power of 3 in our calculator is going to be 8. And 5 to the power of 3 is going to be 125. That's not a 5, but it can be. We'll pretend it's a 5. Hopefully that makes sense. Negative exponents, they seem scary. They're not so bad. They're just unhappy. Put them into a location where they're happy. If they're in the top, put them in the bottom. If they're in the bottom, put them in the top. Thanks for watching.